Picture a chemist in a bustling lab staring at a vat of chemicals swirling ominously, knowing this batch might poison a river if it leaks. But what if that chemist could redesign the entire process from raw material to final product to be safe, efficient, and clean? Green chemistry, as Paul Anastas and John Warner reveal, isn't just wishful thinking, it's a rigorous design science. So how do you turn potentially toxic recipes into eco-friendly masterpieces? Let's crack that code. Before you mix anything, you choose your ingredients, but not just any ingredients, ones that won't wreck the planet. This is where green chemistry flips conventional sourcing on its head. In the 1990s, a team at DuPont switched from petroleum-based chemicals, which are dirty and finite, to corn-derived feedstocks for making safer plastics. This move didn't just cut carbon emissions, it created jobs in rural America. It wasn't easy, but it was a win for the economy and the environment, proof that green materials can make greenbacks. Think of traditional chemical feedstocks like an exhausting highway during rush hour, spewing fumes and chaos. Green chemistry suggests taking the scenic backroads biosynthesis, where natural processes gently build molecules. This approach mimics nature's own assembly lines, cutting down hazardous byproducts and energy costs like a GPS rerouting you around traffic jams. Imagine your trash bin magically refilling your pantry. By using agricultural residues and industrial byproducts as raw materials, chemists close the loop on waste. This circular economy concept transforms what was once pollution into valuable inputs, turning the old linear take-make-waste model on its head. Now you've got your green ingredients, but how do you mix them safely? This isn't just swapping deadly for dull, it's inventing molecules that are harmless yet effective. Alcoa, the aluminum giant, redesigned their catalyst to avoid hexavalent chromium, a potent carcinogen. By engineering a safer catalyst in Pittsburgh labs, they saved workers from exposure and slashed costly waste treatment. This wasn't just a small tweak, it was a game-changer, proving safer chemicals can thrive at industrial scale. Imagine each atom in a molecule as a Lego block. Traditional chemistry assembles castles ignoring toxicity, stacking dangerous colors and shapes. Green chemistry teaches you to swap those blocks for safer versions before you build. It's about redesigning the structure so harmful features never make it into the final product, not just cleaning up later. Switching to safer solvents and designing molecules without toxic tails can improve a product's market appeal. Take fragrance companies. Removing allergenic compounds not only helps consumers but reduces regulatory headaches and product recalls. Safety isn't a compromise, it's a competitive edge. Let's talk lab magic, the actual reaction steps. Green chemistry rewrites the playbook, cutting energy use, waste, and nasty solvents, all while speeding up production. At MIT, scientists pioneered microwave-assisted synthesis, slashing reaction times from hours to minutes while reducing energy use. Instead of heating an entire flask for ages, microwaves target the molecules directly, like a skilled chef grilling only the steak's perfect spots. This leap means less waste heat and faster turnaround in green chemical production. While chem labs have traditionally relied on toxic organic solvents, water steps in as the ultimate green solvent, cheap, non-flammable, and harmless. The authors explain how using water transforms messy reactions into clean, scalable processes. It's like swapping gasoline for tap water, enough said. Catalysts speed up reactions but can also be toxic or wasteful. The book highlights biosynthetic catalysts, enzymes, that replicate nature's finesse, speeding reactions at room temperature and pressure without hazardous byproducts. Imagine miniature machines fine-tuning assembly lines that never overheat or pollute. Remember that chemist staring at the dangerous vat? Now you see how every choice from feedstock to catalyst to solvent can smash that hazard into a chance for renewal. Green chemistry isn't a dream, it's chemistry redesigned with heart and brains. Next time you're faced with a problem, try thinking not just about solving it, but how to stop creating problems in the first place. Subscribe for more book summaries like this one.